Hello guys, here we will going to see solution of one question that is given on the screen. Okay, it deals with the AC circuit. So we know that in that chapter there used to be very important numerical. So you can see I have taken one numerical from the previous year board paper of the 12th class physics. Okay, basically this question deals with 2012 board exam. Okay, so this is the question of the 2012. Now we will going to see here the step by step the solution of this particular question, how we can going to solve such questions, and we will going to get the correct answer. Okay, basically while solving such questions of the LCR circuit, you have to keep in mind what is given in the question properly, and then you have to write the given and then obtain the solution step by step. Just look on the screen, I will going to tell you, or I will going to teach you how to solve such questions very easily step by step. So you have to follow this all the step in the exam itself, so you will going to get the maximum marks. So we will going to start here. Okay, before that, if you have not subscribed this channel, you can subscribe this channel, and if you like these videos, you can share with your friends, and also it will be helpful for them also. So in this question that is given that the 50 henry inductance is given, capacitance is 80 microfarad, and resistance is 40 ohm is given. They are connected to the variable frequency of the 240 volt. So in this question, whatever given as a frequency or frequency voltage, that is a RMS voltage basically. Okay, so we will write in the given itself VRMS. Okay, I am writing it on the screen. So it is 240 volt. Okay, now it is 240 volt, and now I will see what is given again. I have given the inductance, that is 5 Henry. Okay, 5 Henry. Now we have to mention all the quantities in the SI units. So it is 80 microfarad. So we know that we can convert it into, we can write it 80 multiplied by 10 to the power minus 6 farad. Okay, clear. And now I will going to take the resistance, that is equal to 40 ohm. Now we're going to see the solution. So what we have to calculate here, you can see there is one circuit where the resistance, capacitance, and the inductance are connected in a series. So you can see it is a LCR circuit. Now basically here we have to consider some condition at the resonance, because what we have to calculate, this is the question for the 3 marks. So you have to find out the three parameters. First is the angular frequency. So first we have to calculate the angular frequency, which is omega, but we have to calculate that in terms of at the condition of resonance. So we have to find out first omega r. Okay, then the current at the resonating frequency, means we have to find out the current at the resonance. Okay, then we have to find out the RMS potential drop across the capacitors, means what we have to find out, we have to find out the voltage drop across the capacitor. Okay, so first we will find out the solution of first parameter, that is angular frequency. Okay, now what we have to consider here at a resonance. So at resonance, we know that resonance condition is where the impedance of the capacitive reactance and inductive reactance become equal. Okay, so whatever the active or the resultant reactance will be there, or impedance will be there, that will be equal to the resistance. Okay, so at resonance we write omega r as 1 upon under root LC. Okay, that is a basic formula, so that you have to keep in mind. So equal to 1 upon under root, what is the value of L? 5 multiplied by 80 multiplied by 10 to the power minus 6. Okay, so now it will become 8 into 4, it will be 400 multiplied by 10 to the power minus 6. So it will be 400 multiplied by minus 6. Okay, it will become 1 upon 20 10 to the power minus 3. Okay, okay, so it will become, so it will be 50 radian per second, that is omega, or okay, so it is a omega r, that is angular frequency. Fine. Now current at resonance, current at resonance. Okay, so For calculating the current as at resonance, we know that basically in the resonance condition, whatever the reactance of the inductance and the capacitive reactance becomes equal. So basically we know that this is the basic concept that you should know. So whatever the impedance there that we usually call and calculate, that is r square plus xl minus xc whole square, it becomes, now these both are same, so it will become only r, so we can say the z is equal to only r. Okay, so whatever, now I have to calculate the current. So basically current will be I rms, that will be equal to vrms upon z, but z is here r, so I will write vrms upon r. Now, what is my VRMS? You can see that was a 240. It was given in the question. Okay, it is given in the question. And what is the R? That is R is 40 ohm. You can see that is also given in the given section. Okay, so it will become 6 ampere. So we can say that current at resonance becomes 6 ampere. Okay, that is our second question. We got the answer of the second sub question. We will see the third sub question. Now, you can see what way to calculate. Okay, we will going to see here. Okay, RMS potential drop across the capacitor at a resonance. So we have to find out now VC. Okay, now at resonance we know that basically according to the Ohm's law we know V is equal to IR. V is equal to I into R. Okay, now we know the current and resistance. Now for the capacitor, this resistance or this will become XC. We know the value of XC, that is capacitive reactance, that is 1 upon omega c. Now I have the omega also, I have the c also, and I have the current also. Okay, so I will write here vc equal to irms multiplied by, why in the same current, because we know that x l and sorry lc and r means capacitor, inductor and resistances are connected in series, so we know that the same amount of the current will pass through all of these three components. So I will write here v is equal to irms according to the Ohm's law multiplied by xc. Okay, multiplied by xc. So I rms, what is the value of xc? 1 upon omega c. It was 6 ampere. 1 upon omega we got, that is 50 radian per second multiplied by, okay, c. What is the c? That is a capacitance, and we know that it was 80 multiplied by 10 to the power minus 6 farad. Okay, minus 6 farad. Okay, I will write here 6 multiplied by 10 to the power 6 upon, it will become 1.5 multiplied by 10 to the power 3, so it will become 1500 volt. So we can say that voltage across the capacitor at a resonance is 1500 volt. Okay, so this is the final and the third sub question that we have solved here. Okay, so in this way we can solve these questions by using simply the basics of the AC circuits, that we know some formulas and all. Okay, so we should know for this the Ohm's law, the condition at the resonance, and some basic formulas. So we can summarize all this result as omega r equal to 50 radian per second. Okay, second we got the RMS current at resonance. Okay, RMS equal to 6 ampere. Then we got the voltage across the capacitors, voltage drop across the capacitor at the resonance, that is VC equal to 1500 volt. Okay, so all these results are there. I hope you got the solution of this question, how to solve such questions and all. So now by using such methods and by using such steps, you can solve any type of a question which is based on the LCR circuit. Okay, so I hope that you got the solution. Thank you so much.